Good evening, students. So, welcome back to 7th classes. In this video, we are going to discuss intermediate complex theory. That is intermediate complex theory. In this theory, we will discuss about the effect of a catalyst. That if a chemical reaction is happening, then what effect a catalyst gives in that particular reaction, okay, that we study in this intermediate complex theory. So in this, what we study effect of catalyst. First of all, we need to know that what exactly is a catalyst. See, catalyst is a substance which increases the rate of reaction without being utilized in the reaction. Okay, means it itself is not getting consumed in the reaction. Okay, it is what it is doing. It is just increasing the rate of this reaction. What is catalyst? It is a substance that increases reaction rate without being consumed. It itself is not getting used up in the reaction, but it is increasing the rate. If it is increasing the rate, then how it is doing? How it is increasing the rate without being consumed? So this theory states that this catalyst, it forms temporary bonds with the substrate or with the reactant. Okay, it forms those temporary bonds and forms an intermediate. Okay, so according to this theory, what catalysts do, according to this theory, catalyst forms temporary bond. Those temporary bonds, they are not very strong, they are very weak bonds. It forms temporary bonds with the reactants. And by forming temporary bonds with the reactants, it forms an intermediate. And forms an intermediate. See, what is an intermediate? In a reaction, intermediate is that unstable complex, okay, whose bonds are temporary and is not very stable, and it easily decomposes to give the products, and it easily converts into the products. Okay, so that is the function of a catalyst. So a catalyst, it forms temporary bonds with the reactants and forms an intermediate. For example, we are having this catalyst C. In that, I added this reactant. So first it will form Cr. Cr is that intermediate which is unstable. Okay, which is unstable, and then it will convert into the Cp. What is Cp? Cp is the catalyst product complex. Okay, this is an intermediate in which reactant has converted into the product, but that is still attached to the catalyst. Okay, that is catalyst product complex, and then these two, they will separate into C plus P, catalyst and product, they will separate. Okay, so this is that intermediate stage which is transient and is unstable. Okay, and lasts for very lesser time and easily decomposes to give the products. Okay, so this theory says that catalyst forms those temporary bonds and forms an intermediate. Okay, now what exactly, how exactly this catalyst forms the intermediate? How formation of intermediate? Firstly, we have studied that catalyst increases the rate of reaction. How it increases the rate of reaction? That is by forming a temporary intermediate, right? How it forms that temporary intermediate and how that temporary intermediate increases the rate of reaction. Okay, that we are going to discuss. See, I hope that you all know that what is activation energy. Activation energy is that energy which is required to start any chemical reaction. Okay, to start any chemical reaction, the energy which is required, that is called as activation energy. I will write its definition. Energy required to start any chemical reaction. Okay. Now, what catalysts do to form an intermediate, it decreases the activation energy. Okay. Catalyst decreases the activation energy, means that the energy to form the complex to and the energy to form the intermediate, that is decreased. Okay. And that's why the rate of reaction gets faster, the rate of reaction increases. And so rate of reaction increases. Okay. Activation energy is that energy which is required to start any chemical reaction. Okay. If that energy that will decrease to form that intermediate, so obviously the rate of reaction will increase. Okay. Now there is a very important graph in which we show that how this activation energy is different in the presence of a catalyst and in the absence of a catalyst. This graph, this is the substrate, this is the product. Okay. Now, this is the reference. This is the activation energy without the enzyme or without the catalyst. Activation energy without catalyst. But when the catalyst is added, then we get this type of graph like this. Okay. Then we get this type of graph. Now this is the activation energy, the one which I'm doing it with the red color. This one is the activation energy with a catalyst. Okay. So this much activation energy has lowered. This which I have drawn with the blue color, that is the lowering in activation energy, that this much activation energy has decreased. Okay. So this is the intermediate which the catalyst forms over here. This one, that is the intermediate. Okay. See, so how by adding the catalyst, the activation energy has lowered. As activation energy has lowered, and so the rate of reaction that has increased. Okay. So this graph is very important. Okay. So you have to do it for the exam. They will ask this a number of times. They have asked, and a lot of probability is there to ask this same thing, that how activation energy decreases by addition of a catalyst, and what type of graph we get, and how rate of reaction is increased by the catalyst. Okay. So this we have discussed in this intermediate complex theory.